I hope everybody is fine and enjoying the health at your home place. Now, today we are going to study, as you can see on the screen, laws of motion. That is, we are going to study about Newton's second law. So, before you proceed in tutorial, I again let you know that please run through the first tutorial and then come to this tutorial, okay? So that give you a link between what we are going to study now. So, as the topic says, Newton's second law. Now, what does Newton's second law states? Now, according to Newton's second law, it states that acceleration is produced, okay, acceleration, that term you already know, is produced when unbalanced force act on an object, okay, when unbalanced force act on an object. So, when unbalanced force act on object, the acceleration is produced, and more mass of the object, you need more net force to move it. So, basically you can say that with this statement, we are going to derive a relation, that is F equals to ma, okay, that we already have told you in last tutorial, that force equals to mass time acceleration. Now, we will see that how it is feasible and how it is possible. So, as we know that according to Newton's second law, what it says, that the force acting on an object, it says that the force acting on an object is directly proportional to the product of the mass and acceleration produced in the body, okay, by the force. So, this is basically the statement of Newton's second law. But in order to explain the statement, we should know that how it is been derived and how it is been formulated. So, as we all know that acceleration produced in the body, acceleration in a body or produced in a body is directly proportional to the force applied. The more you apply the force, more acceleration you get. And similarly, acceleration produced in the body is also inversely proportional to the mass of the body. That means, if the body has more mass, the force is same, acceleration will be less. As the body has less mass, with the same force, it produces more acceleration. So, that means acceleration is directly proportional to force and acceleration is directly or inversely proportional to the mass of the body. Now, using these two concepts, we can make a formulation that in case of this, that force is directly proportional to mass time acceleration. Just taking the respective terms and relate this notion like that. Now, if force is of 1, and we can also write this particular, that force equals to say kma. So, k is the constant of proportionality, and if we know, or we can say that if force produced is 1 unit, mass of the body is taken as 1 unit and acceleration is 1 unit of acceleration, then by putting these values at the respective location, you can get the value of k. So, k equals to 1. Now, if k equals to 1, the same relation can become force equals to m into a, that is mass into acceleration, and that what Newton spoke of for the or for his second law, that force equals to product of mass time acceleration. So, we will read about this term and we will use this relation in lot many numericals. So, please make sure you should know that how we have derived that F equals to ma, okay. So, basic understanding you should know a simple concept, that acceleration produced in the body is directly proportional to force and acceleration produced in the body is inversely proportional to mass of the body, and then correlate the terms and you get the answer for that. So, as a result, with the same term you will again going to study one more word, one more term called momentum. So, write it down, momentum. So, this is again a new term for all of you. So, what is momentum? Okay. So, momentum is said to be the product of mass underline the word, it is a product of mass of the body and its velocity. Okay. So, momentum is the product of mass of a body and its velocity, and it is represented by a letter P. So, check it out, and since momentum is a vector quantity, so you have to put the arrowhead on it. Okay. So, momentum is the product of mass of a body and its velocity, and as a result it has the unit. The mass, we know the unit is kilogram, while the velocity is meter per second. So, the unit for momentum becomes kilogram meter per second. Okay. So, write it down in your respective copies, because these terms we are going to use it in this tutorial as well as for the next tutorial, because with this word we will use a word again called rate of change of momentum, because force is also said to be the equivalent to rate of change of momentum. So, that we will do the topic after we wind up all the 3 laws of Newton. Okay. Now, again the same statement comes to you, and make sure that you should know the terms again. The Newton's second law states that acceleration of object is dependent, that means depend upon 2 factors. And what are the 2 factors? The net force produced in the body and the mass of an object. Is it clear? The net force produced or net force acting upon the body and the mass of the object. So, on these 2 factors the Newton second law depends. And then there is one word that we already have told in tutorial 1, something called weight. Okay. So, won't get confused now with weight and mass, they are 2 different things. So, as far as weight is concerned, we call it is m into g, while the g is the gravitational pull of the planet. In this case we talk about earth. Okay. So, in order to overcome the gravity, to lift the massive body, you have to apply an upward force, which is ma, because we have just told you F equals to ma. Okay. So, you have to apply enough force to lift the body that is greater than the downward acceleration or downward gravitation called mg. That means, whenever you want to lift a body, you have to apply that much of force, which should be more than mg. G is gravitational force. Okay. That is why you can't lift the heavy stone individually, because in this case the mg is more than your lifting force called ma. So, if the lifting force ma is less than the mg, the body will always remain heavier. Okay. So, in order to lift it, you have to have force which is more than mg. Make sure these 2 terms are quite correlate, and so we should be knowing about it, ma and mg. Okay. Now, according to this we have again the same statement that says that the acceleration of an object is dependent upon 2 variables, as I have told you, the net force and the mass of the body. Net force and the mass of the body that acting on it. So, as the force is acting upon an object is increased, the acceleration of the body is more, and if the mass of an object is increased, acceleration will go down. So, underline the statement that more the force, more the acceleration, more the mass, less the acceleration. That you can see in the flow chart also, that the unbalanced force act, acceleration is produced, and the acceleration directly depends upon the net force. Okay. And the acceleration depend inversely upon the mass. That means it depend inversely. Make sure the word inversely there. Okay. That means if mass is more, acceleration will go down. If mass is less, acceleration will go up. So, in these 2 terms should be very much clear in your mind. So, because when you read about the statement and the various type of numericals, you should be clear about it. Now, after knowing the law of Newton's second one, now you should know its application, because application is basically the main part of this chapter. Okay. Because application give you lot many questions. So, they say that we know a word called rockets, this travel through space. Then basically it has all the 3 laws of Newton, but let us see the one which is concerned with. They say if the rocket needs to slow down the speed up or change direction, a force is used. Say the rocket is moving, you want to slow down or change direction, you have to give a force. So, the amount of force and the location where it is providing the push changes either both the direction or the acceleration part, means the point of application of force. Point of application of force do play a vital role in the body's motion. Okay, point of application where we are applying the force on that aspect. In case of the body in motion, it changes the direction or its acceleration. Now, in this case, we have just told you that in case of momentum, we have just let you know all this thing. It is a product of mass time velocity and it is a vector quantity. So, make sure all these things should be known to you. Now, just see the explanation for the second law's examples. Kicking a ball. They say when you kick a ball, what you do is that we exert a force in a particular direction and in that direction the ball travel. In addition, the stronger the ball is kicked, the stronger the force will be on it and further it will go. That only it says more is the force, more is the acceleration and the body travel the distance. Same is the case of pushing a cart. So, you all have seen that when you push an empty cart in a supermarket, it is easier, but when you load it, the pushing becomes a bit more difficult. Why? Because the cart now has got some extra mass. Okay? So, as I have told you, if mass is more, you have to apply more force. Now, this is a good example. You might have observed it in basically that when the two people go for walking. So, what happens is that is say among the two people walking, if one is heavier than the other, then the one weighing heavier, that makes sure walk a bit more slower as compared, because acceleration of the person weighing lighter is greater than the other one. That means if the person M has got more mass while the person say M2 has got less mass. So, in that case the person having less mass will be getting more accelerated, because the acceleration of the person weighing lighter is greater. Hence, you will all find that if the two person walking, if one is having less mass, he basically walk faster than the other. Same is the case here. You can see the example give you a good illustration that greater the mass of the object, more force we have to apply. You can see if the body is weighing say 400 kilograms, the force applied will be massive, we can't move it. But if the body is less weight or less mass, you can see the person can move the body better. And similarly, you all might have seen this also, those who play the game of cricket or anything, baseball like that. If the ball is lighter, you hit with the bat, it go for longer distance. If the ball is heavier with the same force, it just fall nearby you. That means in order to get the body farther, if the application of force is same, the mass of the body should be always less. Okay? Then only the body travel a longer distance. I already have told you regarding the walking together people. On this example again the same thing, that when I apply the same force on two bodies, one is the golf ball, other is the massive truck, the common sense prevail. If the body mass is less, it will travel long distance. For case of truck, you can only laugh it off, because for that the golf stick won't have that much of force to move it. Now, in order to move further, these are some explanation, you should be knowing it, because each explanation give you the questionnaire. So, write it down that why it is easier to push an empty cart than to push a car is easier than to push a truck. These things should be known to you, and this is the again good example for the people, those who play the game called cricket, that when you catch a fast moving ball, what you do it? You put your hand or take your hand backward. Why? Because you increase the time period, and when you increase the time period, the force impact reduces or injury time goes down. So, though it is a good example of your everyday life, you should also know that while you catch a hard hitting ball, then you have to take a proper posture and position because of the laws of physics. Similarly, we use a seat belt to prevent injury, because when the car is moving with a large momentum, I have told you momentum is what? Mass time velocity. So, car has got maximum momentum at the time, and something happens say uncalled for, So it is suddenly reduced to zero momentum in a very short time. So as a result, the person sitting in the vehicle might get injury by banging the head in the window pane or dashboard. That's why he or she has to be given a seat belt and should wear the seat belt. That is the importance of seat belt. You can see it. Similarly, we have seen that when athlete take a high jump or that long jump or high jump in particular, we provide a cushion to the one. Why? Because to reduce the momentum when the athlete falls on the respective zone. Similarly, kicking the ball, I have told you, tug of war game, you know the game that when you apply the force on the two respective teams when they play this game, so the one that will apply, the two teams pull the rope, in this particular game in the opposite direction, and the team which apply the larger force ultimately wins the game. Now comes the third and final law, you can say, for this particular topic, Newton's third law. So it states that what? That to every action there is equal and opposite reaction. Make sure what it says. To every action there is equal and opposite reaction with the same momentum and the opposite velocity. Same momentum but in opposite direction. Okay, so you can see here the simple example that what happens when you inflate the balloon and release it by just unknotting the knot. So what happens is that the air of the balloon that you have used to blow it pushes the balloon down, okay, and this air which is going down get the reactive force that push the balloon up. So to every action there is equal and opposite reaction. Same the case you can see here when the boy is jumping from the boat. So what is the action? The boy feet exert force on the boat, and what the reaction? The boat exert force on the boy. So in both the cases that action and reaction is being taking place. That what Newton spoke of. That's a statement. Again, write down the statement means that in every interaction there is a pair of force. Okay, underline that word. There is a pair of forces that are acting or interacting, and the size of the force on the first object equal to the size of the force on the second object. Underline this last term. The force magnitude on both the cases are equal but in opposite direction. Now here is the first application for the Newton's third law, that when a rocket moves in space, it pushes the gas outside from it, and the rocket applies the force on the gases in the backward direction. And what happened to the reaction? The gases pulls with the equal amount of force, make sure, in the opposite direction, and as a result the rocket shoots up. The same thing happened as I have told you in that case when in particular we people have this particular walking zone. You should know that how you walk and what is the reason behind your walk line. So they say when you walk, what you do, you push the street or the road, you apply a force on it, and the reactive force moves your body forward. That means when you walk, basically you are pushing the earth, and the earth gives you a forward motion, okay. And this is one example called recoiling of gun or gun firing. What happens is that when someone fires the gun, the reaction force pushes the gun backward, okay, that we call recoiling of it. So we'll read about it further, that when you fire a gun you also get a reactive force in the opposite direction. Then similarly when you jump to land from the boat, I have just told you this is the particular explanation. You can see it, the reaction and the action of the both cases. And rocket, as I have told you just before that, in case of again the rocket, what happened is that from the exhaust the gases comes off like that. That is the force action, you can call it. The reactive force pushes, that is of the gases, pushes the machine or the rocket in the forward direction. Same is the case, you can see you already have using this type of game every day, bouncing of the ball. So when the ball hit the ground, in what happened is that, or the wall body, the apply force on the wall or on the ground, the wall or the ground apply the same force on the ball. So this is the action, and the ground force is the reaction, and that's why the ball keep on bouncing. So you should know why the ball bounces. Now these examples are again for the third law. You should know it, that in case of swimming, what normally we do, the water is pushed backward by the swimmer, and in turn the water pushes the swimmer forward. The man walking on the ground, I have told you, apply force on the ground give you a force back. Same is the condition with the bird flying in particular, that should also be known to you. So what happens is that in case of the flying of the bird, so while bird fly, they pushes the air downward, okay. When they pushes the air downward, if it is a bird body, when it fly with the flapping wings, it pushes the air downward with the wings. And what is the result? According to third law of motion, the air which is pushed down get a reactive force and the body get a lift, okay. As a result, the bird keeps flight or be in air or it be airborne. And the propulsion of the automobiles is the same case. What happened is that, so principle is same for the automobile principle. So when you start the vehicle, the wheel spins and grip the road because of friction. As a result, the force, the resultant of the force pushes the road backward, and the reaction, what is the reactive force according to third law of motion? The same equal force act on the wheel but in the opposite direction. As a result, what happens? The vehicle moves up. The same thing happens in case what happened if the same scenario has been resulted on, say, on the ice. What happened in case of the surface of the road was ice. If the example they assume it, they say the wheel won't get the enough grip properly because there is no friction. Hence, it would be difficult to exert a force. That's why our automobile find it difficult to move ahead on the icy surface, or hence they skid off. So you can say all these examples have connected with the Newton third law of motion. So in all these cases that we have just read, that how the rocket travel and what are the way the pushes are obtained. Now this is a good question here. They say in the space, we know that it is vacuum. So what can, somebody can ask that, what can a rocket push against the vacuum? So what all happens? So what they say that when the rocket starts in the space, you say when the rocket is started in the space, hot gases are present and released in the downward direction of the rocket, okay. So write it down properly, understand the topic. So when the rocket is started in space, the hot gases are released in downward direction of the rocket, and this result in the equal size upward force on the rocket that pushes the rocket ahead. And this is the classic example of Newton's third law of motion, because in that case, since there is basically vacuum zone, then the mechanism of Newton's third law is better explained. Now, push the force involved in different masses, as I have told you that if the two body had different masses, then there will be different effect of it. So they say take examples, say two teenagers standing on the ice facing each other. That is a good example, okay. Just try to visualize it. They say the two individuals are standing on the surface which is icy, okay. So make sure and assume there is no friction because they are on ice surface. So the weight of one of the teenager is more than the other. Say they say weight of any one is more than say m2 example. Just consider it. Now they push each other in the opposite direction to each other. Here the question is who will move away from with a higher speed among the two boys, say for example. Now the reason what they say, as the mass of one of the teenager is greater or one of the boys greater, his speed will be lower, because we know that if mass is more, force will be approximately, oxygen put in the body will be less. So as the mass of one of the teenager is greater, the speed is lower. So the lighter boy will move faster and farther away. So you can see in all these examples how beautifully the Newton's third law is explained. Now this is the term or the topic that we will be taking care of for the coming chapters as well as tutorials, that what is a gravitational force, okay. So this is the force exerted by the earth, okay. Now sometime you might have wondering the things that due to the gravitational force exerted by the earth, the ball follows the projectile trajectory. That means if you throw a ball up in the air, it moves and comes down like that. So we call it a projectile trajectory, okay. that it gains the height and come back. The question is, if the ball is coming back to earth, then why not the earth goes towards the ball side? Sometimes you might ask that why only the object falls to the earth, why not the earth goes towards the object? So though some of you might be knowing the answer, but for the other people to get clarification, you just see that when it hits the earth, the ball applies the same force, but in opposite direction. Then I have told you the question is, then why won't the earth move towards the ball? Why? Because there is a huge difference in the mass of the earth and the ball. I hope some of you know it. What is the mass of the earth approximately? You can say it is 6 into 10 to power 24 kilograms. It is unimaginable number for us, while the weight of the ball is how much? Just 50 or 100 grams more or less. So you can see you can't compare the 10 to power 24 kilograms to just 50 to 100 grams. That's why you will never find that the earth will go towards the ball. It will always, the ball will fall towards the earth. So please go through the tutorial again properly, read the topic, make your own questions, and put these answers in your respective copies and learn them. For the time being, take care and